Hey, AP Chemsters, this is Mrs. Vanderlei bringing you part two of Blankwalle 4.2. If you recall, part one was all about stoichiometry. And what is stoichiometry? It's really about a measurement. So you're measuring one quantity to another quantity of a balanced equation. So the first thing you have to do is write down your formulas correctly, then you have to balance it. Then you have to fill out the BCA. B stood for before, C stood for change, and A stood for after. And what did we say the quantities had to be in this BCA table? It was the mole. So everything in the BCA table, must be in moles. So we learned what a mole ratio was too. The mole ratio is where you took the coefficient of what you know. So you're going to divide the quantity that you know by the coefficient of what you know, times it by the coefficient of what you want. Okay, so we're going to start doing problem number two. And before we actually get started, I just want to, speak from my heart a little bit. First of all, you should have a calculator out with you. That is really important. You need to be making your own calculations. Make sure you understand where I'm getting these numbers from. Number two is when I say pause this and do it on your own, I really mean that. And that is the power of the flipped classroom, that you're just not blindly copying down my work, that when I tell you to pause it, you're doing the work and then you're checking your answers. I get the feeling that not everyone is doing that. They're just writing stuff down to write stuff down, and you're not learning. You learn by doing, you learn by watching, you learn by checking your answers. So once again, when I say to pause it, actually do the work, and then come back and see how you do. That's what you really need to do to learn this stuff, okay? We're going to do many of these throughout the year, so it's to your benefit to learn it and learn it well now at the beginning, because if you don't, you're just going to get more and more behind as the year goes on, okay? So that's enough of my sermon, so let's get started. Problem number two, do you have your calculator out? What mass of oxygen will react with 96.1 grams of propane? And you should recall what propane is. Maria eats peanut butter. This is propane right here. It has the 3 carbons. And look at this, 3 times 2 plus 2 is 8. That's your propane. And when you combust it, here's your oxygen, you have carbon dioxide, and you're going to make some water. You probably knew that already, didn't you? So what's the first thing you need to do? Balance it. Why don't you go pause this, really, and balance it yourself. So this is what I got. Hopefully it's what you got too. If you're calling, I'm going to balance my oxygens at the end. So do your carbons and hydrogens first, and you should get these numbers here. All right. So what mass of oxygen react with 96.1 grams, yes, periodic table, of propane? Hey folks, what goes in here? Moles. So what do you think you have to do with 96.1 grams of propane? Convert to moles. So why don't you pause this, do your work over here, and find out how many moles of propane you're given. All right, so how'd you do? So I put, hang on. All right, so hang on. I hope that's the end of all my computer notifications. All right, here we go. Let's try this again. So I'm trying to find question mark moles of my propane. I'm given 96.1 grams of propane. Look at the molar mass for a minute. I thought that was carbon dioxide, but it's not. It's the propane molar mass. I got 2.18 moles. So where do I put that 2.18 moles? That's how much I actually start with, isn't it? So I'm going to put that right here. Now let's finish off the rest of the 4. How much oxygen do I start with? I probably have a huge room full. I have as much as I need. How do I know I have as much as I need? Because they didn't tell me how much I have. So if you ever have, a situation where they tell you, one of your reactants but not the other one, assume your other one is in excess. And once again, that's your abbreviation. Well, how much of my product do I start with? You always start with no product, correct? You always start with no product. So that's what this is going to be too. Now, which is the quantity I know about? I know about my propane. So I'm going to subtract that out. Here's my change. So this is my given, right? So when I do this, take the 2.18, divide it by 1 times 5. And what do you get? Did you get 10.90? Why don't you do the same thing for carbon dioxide and water? Come up with these mole ratios. Divide by 1 times 5. That's what this is. So divide by 1 times 3. Go for it. Did you get 6.54? And what about the water? What did you get for that? I hope you got 8.72 because that's what I got. And so notice I am subtracting out from my reactants. I'm adding my products. Why? Because as a reaction is going on, I'm losing my reactants. As the reaction goes on, I'm gaining more and more products. All right, so now do your subtraction. You should get a 0 for that one. And what's a whole bunch minus 10.90? That's going to still be excess. You still have plenty. I don't know how much, but you still have plenty. And then now we have 6.54, and now we have 8.72, okay? So that's my mole ratio. So the change right here is my mole ratio. And now what's left to do is convert how many moles of oxygen of 10.9 I use. I'm answering the question, but I don't want moles, I want mass. So now you need to go ahead and convert that. Why don't you pause this, see how you do. All right, so this is what I have. I have 10.9 moles, and I put moles at the bottom, 32 grams on top. I got that from, the periodic table. And I got 349 grams of oxygen. Notice I only have 3 sig figs. I probably should have changed this to only 3 sig figs, and because this is 3 sig figs. Okay, so that's how many grams of oxygen that you used to completely combust 96.1 grams of propane. Okay. Now, could we ask you a whole bunch of other questions? Sure. How many grams of carbon dioxide did you make? How many grams of water did you make? Hey, how many liters of carbon dioxide did you make at STP? So you can have a whole bunch of questions from this BCA table. So when you're filling it out, all that left is to answer the question. What specifically do you want from here? That's the power of that BCA table. You can answer almost anything once you fill it out correctly. Okay, let's go on and see what the next problem is. All right, so you can read the problem. You're going to be doing photosynthesis. You want to determine a particular plant consumes 37.8 grams of carbon dioxide in a week, assuming there is more than enough water. So what do you put underneath water? Hopefully you know, remember it's excess to react with all the carbon dioxide. What mass of glucose can the plant synthesize? All right, so what I'd like you to do is try working out the entire problem. All right, so you're going to pause this for a little bit, aren't you? All right, so you need to balance it. You need to convert your grams to moles. You're going to fill out the BCA table, and then you're going to answer the question. So when you are done, please really do it. I mean it. When you are done, come back and let's see how you did. Okay, I'll give you some time to pause it, right? All right, well, the first thing I do is balance it. Hopefully you recognize the 6661. And so then my given over here, I had moles of carbon dioxide, or I'm sorry, that's what I'm looking for. I have grams of carbon dioxide, so I convert to moles. Notice I put that over here, under here. I put excess under the water, and of course, zeros under your products. And you can take this, divide by 6 times 6. It's the same number, isn't it? You take this, divide by 6 times 6. It's the same number, isn't it? And you take this, divide by 6 times 1, you get 0.143. And then you can fill out your BCA table. You subtract, subtract, add, add. Okay. Now, what is it that you're looking for? You want to find the mass of glucose. So here we go. We want how many grams of glucose? Sorry, I didn't write the whole thing out because it took too much. And I took the 0.143 moles, multiplied by its molar mass. I got it from the periodic table, of course, and this is what I got of glucose. Okay. Hopefully that worked out pretty well for you, and hopefully I didn't make any mistakes. Okay. So let's see what problem number 4 is. All right, so magnesium hydroxide, the active ingredient in milk and magnesia, neutralizes stomach acid, which is mostly HCl, according to the unbalanced reaction. Oh, what do you think you have to do? All right, you need to balance it. So it says, what mass of HCl is neutralized by a dose of milk and magnesia containing 3.26 grams, periodic table, of magnesium hydroxide? So once again, pause this, really do it. So you got to balance it, you got to convert your grams to moles, do your mole ratio, and then answer the question, all right? So I'll let you have some time to pause this, do it, and come back, see how you did. Well, hopefully you balance it by 1, 2, 2, 1. That was pretty easy, wasn't it? I need moles of magnesium hydroxide. Here's my grams, periodic table. There's my full thing. And now we have this many moles of magnesium hydroxide, so I put that under here. What about HCl? I have excess. I have plenty. My stomach doesn't run out of HCl, doesn't it? And I start with 0 of water and 0 magnesium chloride. Once again, take this down. So you drop this number down. So 0.0559 divided by 1 times 2 is this. Same number again, and then 0.0559. Okay, so subtract, subtract, add, add. So what is it that we're looking for? We're trying to find what mass of HCl. So it's right here. This is how much is actually used. Okay, so you want grams of HCl. You start with 0.112 moles. Here's my molar mass. Where did I get it from? Periodic table. And there's my grams of HCl. Okay, let's see what problem number 5 is. So why don't you go ahead and do number 5, balance it, convert your given to your moles, and fill out the BCA table and see how you did. Go ahead and pause this. Really, that means you. All right, so we know we had 31.8 grams of zinc. So I convert it to moles. Oh, by the way, here hopefully I balanced it right. And so I subtract out, add, add. And then what are they asking for? What's the weight of zinc phosphate? Well, this is not the weight, this is the moles, isn't it? So go ahead and calculate your mass of zinc phosphate. Well, how'd you do? Zinc phosphate has a pretty high molar mass, doesn't it? Hopefully you got the same numbers that I did, and you end up with 62.5 grams. Now, what do we do about letter B? We haven't talked about volume, okay? You might recall a very special number from your first year chemistry class, and that's 22.4. So that is the volume of 1 mole of any gas at STP. So they don't tell you the other conditions, assume it's at STP, and there is something else. So to convert moles to liters of a gas, nothing else, no liquids, no solids, okay, just gases, you use 22.4. One of the biggest problems I've seen here is that you want to start finding, volume of a solid or something like that, and they use 22.4. No, you'll need to use density probably for those kind of things. As long as you have a gas, you may use 22.4 liters are in 1 mole, okay? And so when I did that, I got 10.9 liters, okay? Could I ask you maybe how many molecules are being used? Sure, then you could use the 6.2 times 10^23. Don't forget that equivalence between moles as well. Okay, let's go on. All right, well, we are done with 4.2. 4.3, I'll just kind of preview this. Up until now, we have been dealing with, let me go back. There you go. Where you have only one known quantity. I gave you a specific, let's say about carbon dioxide. I said, oh, we have plenty of water. Down here we have a specific of magnesium hydroxide, but oh, we have plenty of HCl. Over here we have a specific amount of zinc, but oh, we must have plenty of phosphoric acid. Okay, so what happens if I give you the quantity of both? That's what section 4.3 is going to be all about. So what you're going to be doing when we meet next time is go. Well, all right, hang on. If you look at this, a linear reactants which is used up and is determined the amount of product. So we have to make sure that we figure out, well, if I'm giving you both quantities of each reactant, which one runs out first? So we're going to find out which one then is a linear reactant and which one is an excess. 4.2, I basically told you which one runs out and which one is excess, okay? So I'm going to leave you with that. I'm done with 4.2, so of course I'll say, hey, don't wait to be great. See you next time. Bye-bye.